Welcome, everyone. Today is Tuesday, April 15th, 2025, and this is day two, week two of Hotel Evening and Weekend Platoon. Yesterday, you had Umar as an instructor, I believe, and you guys went over all kinds of different loops. Any questions about yesterday's stuff that you didn't get to with Umar by chance?
No questions.
We're good with loops in JavaScript and Python. I think it was in both languages, if I remember the curriculum.
If we have time and you want to show it again, I wouldn't be opposed to seeing it again. But I mean, I might ask that every day though, just 'cause it's good to see it again. But you don't have
Is there a
to.
specific problem in mind?
No, it's just I just like to see the workflow again. But don't go out of your way to do it. If we got stuff that we got to knock out today, it's all good.
Okay, if there's time, I'll definitely go back and do it. Today's is pretty similar to yesterday's. It's high order functions. We'll get into why it's similar here. What's this? What should let me do just let's see, let me see your challenges real quick. Factorial, linear search, and palindrome. Okay, I'll pull them up, yeah. These are pretty straightforward. Okay, cool. Any other questions, guys? Yeah, we'll do them towards the end of today's lesson because they kind of fall in with today anyway. Any
Cool.
other questions, guys? Alrighty. If there's no other questions, I'll go ahead and share my screen here. Share my screen. Let me go with this chat. Okay, no worries, Adam. As long as you're with us, you're fine. Okay. Let me bring this out here. Okay. Can you guys see my screen?
Yes, sir.
All right, today we're going to talk about high order functions, for each map, filter, reduce. High order functions are really not any different than the regular functions or the regular loops that you've already learned. They are what's known as syntactical sugar. Sometimes you'll hear that phrase, sometimes you won't. If they're an OG programmer, you will hear it. It's just syntactical sugar is just like a fancier way to code something out. But under the hood, its implementation doesn't change at all. So it's not any more optimized or anything. Does it look prettier when you write it? Yes. When you do like a high speed arrow function on your leak code to solve it, does it look fancy like you know what you're doing? Yes. But just know that under the hood, it's not any more optimal than anything else. Does that make sense? Yes? That's a really important thing to remember. Really important thing to remember. So here, right here, you just have your OG loop. This is a normal JavaScript loop where you're iterating over a list called myR. You give it the length. What are the three components of a loop? Can anyone tell me? They're broken up by semicolons right here. This is one. This is two. And then the list, this I++ is three. What are the
Is it
components?
the start, end, and step?
Yep. Start, stop, step. That's how you remember it. Where do you want to start? Where do you want to end? How big of a step do you want to take? Do you want to go one by one? Do you want to go every other step? Do you want to go by threes? Do you want to go by fives? Does that make sense? So when you iterate backwards with a loop, you always start at the back end, right? And it's always, array length or string length -1 because it's zero indexed, right? And then you go to what? So it's greater than zero because at zero, you're out of numbers. Greater than or equal to zero, I should say. And then you go I minus minus. Make sense? I minus minus is just a shorthand for when you go I++, that's just JavaScript for, this and this is exactly the same thing. Does it look super high speed when you write it like line one? Yes, but it's no different than line one. Than line three, I should say. And this is just a shortcut. What if you wanted to go by twos? Can you use line one? No, you would have to do something like line 3, right? Going by ones in programming is so common that they just give it its own special syntax, right? If you ever look at the programming language C++, that originated from which programming language, do you think? From
Python.
C.
Guessing C.
No, just from C.
Yeah, that
And they're
makes
like,
sense.
hey, this is a new version of C++, so they did C++. And it means exactly what you think it means, +1 version. That's it. Make sense? Don't overthink it. It's not anything any fancier than that. Okay, easy enough. So this is just a normal loop. When you do a slightly fancier version that you covered yesterday, I'm sure, is instead of a normal for loop, it's a for. If I want to iterate over that same loop, if I wanted to iterate over that same loop, so this is my array. This is my normal loop. If you didn't need the index for anything, you could do just let num of my R, right? Console log, just num, right? That would do the exact same thing. We got rid of, I mean, obviously this is a template string, but if you removed it, these two things are exactly the same, right? Right? Yeah, exactly the same. And if I wanted to do my R for each, and we're going to get into this in a second, and I wanted to do something to elements, right? And I want to multiply every element times 2 and double it, depending on exactly how you were storing the values, or if you were storing them, all three could potentially do the exact same thing. All three, this line 5, line 10, and line 14. All doing literally the same thing. Is one more optimal than another? No. Is for each super high speed and it looks nice? Yes. But as time passes, languages evolve and they add new things to it, right? And a lot of the high order functions in JavaScript came, I want to say post 2015 or 2016. ES6, they call it. ES6 things. So they just add stuff to a language. Nothing happened to the original for loop. They just then added the for each loop or the for of loop. Make sense? And Python, I'm not going to get into Python right now, but Python's really not any different. Okay, here's a little question for you. So you studied this yesterday. What's the most important loop in Python if you only had to pick one?
For in?
Yeah, you're being way too broad. Be very specific as to how you describe it. For in applies to at least 3 different kind of Python loops that I can think of. I'll give you the same question for JavaScript. What's the most important loop in JavaScript? If you only had to learn one, which one can do it all? I mean, you can finagle the rest to kind of give you everything, but that's going to be really painful. If you had to only learn one, which is it?
For loop.
Which one?
That one you have right on front of the screen with the start, stop, and end.
Line 5, right?
Yeah.
Right. And the most important one in Python would be for I in range. Right. And in Python, you have a bunch of stuff that you studied yesterday. Enumerate. You have the normal for I, for num in, my R, or whatever the case may be. Right. All of them have their use cases, but if you don't have to pick one, the for I in range can do everything. Similar to JavaScript, this one can do everything. Right. You wouldn't even need a for in loop, right? If you need to iterate over keys in an object, right? You could put it into object.entities, right? Throw in my object, and this could even iterate over an object if you wanted to. Right. So not all loops are not created equal. Make sense? So if you only needed to pick one for loop, it's this one. Right. Same thing with jobs for Python, the for I in range loop.
Right.
right? Could you finagle the rest? Could you grab the indexes from line 24? Like if you're doing Python for num in my array, could you do it? Yeah, but then you'd be stuck in here nesting loops like my R index of num. You're probably stuck in here, you know, uh, new index, right? Now you got nested loops and that's messy. So can you finagle the rest of the loops to give you what you want? Yes, that's really impractical. Just use the appropriate tool for the job. Make sense? So just remember that languages over time evolve, and that's why you have just a lot of different ways. And like any programming language, a bunch of different ways to do the same thing. So fancy, syntactical sugar, not necessary. Everything in programming, if you remember your live technical assessments, what do we assess when we first evaluate you? Loops. What else? Variable assignment, reassignment. I don't even think reassignment is hyphenated. Assignment. What else?
Pairs,
What?
the key value pairs.
Objects. Yeah. Key value
Manip-
pairs.
Manipulating strings.
Yeah. Manipulating strings, arrays. Everything in programming can be done with those things. Every single thing. There's nothing outside of programming that can't be done with that. There's nothing more to it. That's the reason why we try to evaluate those things. Make sense?
Yeah.
There you go. Okay, so this went over the normal loop. There are many number of variations to this pattern. We just kind of talked about the different kinds of loops. Here, if you wanted to do this, this is just an old school version of which of the high order functions. Does anyone know?
It looks like the for each.
Not quite. What is this doing? This loop is doing what?
It's basically iterating iterating through the array and taking the element in the array and multiplying it by 2 and then pushing it to a new array.
All right, so it's doubling the number of the initial array and creating a new array, right?
Mm-hmm.
This is just a long way of doing map. This is just .map. That's all it is,
Okay.
right? So I could have some number, right? And I could just do number times 2, times 2. This is shortened. This is effectively saying, hey, loop through every element in my array,
Mm-hmm.
create a new array, and do this thing to every single element.
Mm-hmm.
That's it.
Is there ever a situation where you would do the long way instead? Or is it just better and faster?
So a really important thing to keep in mind is the last part that you said. It's never really better or faster, at least not in its implementation. Now, does it look nicer? Yes. Is it less code sometimes? Yes. But it's not optimally faster, right? So I always encourage everyone to get really good with the basics. And then off of the bases, you can do anything else. Right. I've seen people memorize a high order functions. This happens a lot. People will memorize a high order function. And if you remember your technical assessment, I never let anyone typically use high order functions. And then you'll be surprised the number of students that say, oh, well, if I could use the high order function, I could do this problem. Let me repeat that, because that's a really important thing that people bring up to me, saying, well, you're not letting me use these high order functions. If you let me do that, use them, I could solve this problem. What point is that student missing?
That it can be accomplished without it?
Exactly. They don't understand that this is no different than this. So what you're effectively telling me is you don't know how to do it. And you don't understand a very crucial point of programming, right? That everything is a loop under the hood. How do you find the index of something? How do you find the index of a character or an array? A character in a string or an array? in JavaScript? Does anyone know? What's the method? It's called what?
Dot index.
I think it's index of actually. It's this,
Okay.
right?
Mhm.
Right. And in Python, what is it?
Dot index.
Dot index, right?
Mhm.
Under the hood, these are just linear searches. Remember your assignment from last week? Right. This is seeing a string of some hot dog, right? Or whatever list. And the only thing it's doing, it's going to the very first character and saying, hey, are you this character? No. Okay. Goes to the second one. Hey, are you this character? No. Okay. Goes to the next character. Okay. Goes to the next character. Are you it? No. Next character. That's all it's doing. Right. So these right here under the hood are just this. That's it. They're just linear searches. Make sense?
Mhm.
So when I was saying, hey, if you had to pick a loop, which one would you pick? That's actually really important because if you have to then pull it, let's say you're doing in Python or just in JavaScript, doesn't really matter. Let num of R or my R, my R. You're doing this loop, and then you don't have the index. So then you're trying to find let new index. You're trying to find it. Then you have to do my R dot index of num, right? You just nested loops there. This is a linear search nested inside of a linear search. All right, and we'll get into time space complexity, but then you start writing really inefficient code that eats up a lot of resources that gets, and when people say, oh, it's really expensive, when people talk about expense in programming, they're talking about two things. They're talking about the actual money, right? Computer memory, right? Something's expensive, or they're talking in terms of time. It takes too long, so it's an expensive call, right? But ultimately, if something's an expensive call and it takes a long time, it's probably costing you a lot of money because of some inefficiency on your back end or something, right? So it ultimately does come down to dollars. Does that make sense?
Mhm.
So there you go. Okay, cool. And this is just the old school way of doing map. So understanding high order functions, things like map and reduce and everything, doesn't necessarily make you a good programmer, but having more tools in your tool belt will definitely will, right? Especially when you interview, you're going to come to realize that when people watch you code, or you're explaining something, or you're kind of under the gun a little bit, you're going to realize you're going to forget a lot of the stuff that you know, right? So the more tools you have, even if you forget half of them, you still might be able to solve the problem. So the more ways you know how to solve something, the better you're always going to be, not only on the job, but also in interviews. Yes? Okay. And kind of as a side point, when you get ready to interview, make sure to have 4 or 5 anecdote stories, right? That cover all the basic behavioral questions, right? Don't reuse the same story, right? Because typically you're going to interview with a handful of people. And if all the handful of people have heard the same story from you, they're going to think you don't have a lot of experience. But if all of them have heard a different story from you, they're going to think you have more experience than you actually do. So that will be in your best interest. Kind of a side note, but keep that in mind. Okay, so here we go. So this is just the old school doing map. Here it talks about writing functions. Why do we write functions? Does anyone know?
Is it for organizational purposes?
Yeah, it's partially for, well, it's in a large part for organizational reasons, but also so you can do what to your code?
Compartmentalize it.
Compartmentalize it. Also, what else? Probably the
Repeatable.
So
most
you can
important.
reuse the
Repeatable. Yeah,
function.
you can reuse it. Right. If I wrote my code, and when some people start out, they always do this, right? They just start writing to solve the challenge. Nothing's ever going to be free floating like this. Everything's always going to be within functions. Everything's within, and when you get to your job, it's going to be within classes. So everything's going to be encapsulated, so it's reusable and easier to manage. right? You're not just going to write this loop in a million different places in your code base, right? You're just going to import that class, use that method. That seems kind of like an abstract thing right now, but reusability and maintainability is really, really, really important. I'm not quite sure if this lesson gets into it, but when you write a function, right? Some function do something. This is my function do something, right? Some param. Sometimes I'll have people do this. They'll do let I equals 0, and then they'll do, I is less than 10, I plus I plus plus. What's wrong with this kind of function? What's wrong with function 29 on line 29?
There's no end, the return. No
Yeah, I
return.
mean, I could do return something. Return something. Good catch, but that's not really
Oh.
where I'm trying to point you at. Look at the loop.
Well, it's not doing anything. It's incomplete.
Besides that, that's fine. Assume it is complete. Something really wrong with it. It look like that.
You haven't established a basically you're trying to loop through an array, but you don't have the proper length for the array set aside.
Yeah, you're walking around the
Or
right answer. So what's wrong with it?
you're not using it, I guess is what I'm trying to say.
I'm not, yes, yeah, you're kind of walking the answer here. But look at
Mhm.
line 7. You're not using it, yes, but what's wrong with line 7 specifically?
I is less than 10. I don't see anything.
There's nothing wrong with line 7.
Yeah.
Is there some up with the condition there?
Well,
Because you can't. There needs to be like it's just an integer there, and you actually have to put a condition itself. So it would need to be like
Yeah. Yeah, this is an example of a hard code. It's something you would never do in
Yeah.
programming, right? So your function needs to be dynamic and also needs to be agnostic, right? So it needs to understand what it's being passed into it, right? And it needs to adapt to it. Right? Sometimes people will see this with a 2 for, there's 5 elements, and then they'll be like, okay, well, it's 0 index, so I'm going to put a 4. I'm going to put it right here because the sum param, right? It's 6 elements. So it's not going to go past 5. Sorry, past 5 because that's 6 elements, 0 index. And then I'll say, well, what if it takes a list that's a million elements? It needs to be dynamic in that way, right? You can't hard code this. Why? It's not very reusable. I need to be able to use the same function for a list that's 3 elements as opposed to a list that's a million elements. That same function should work and should be reusable.
Mm.
Right? Especially if it's doing something very simple, like simple arithmetic or very common thing, right? Loading some kind of file or logs to an S3 bucket or real application, right? Or sending messages to update someone that something is broken or there is a vulnerability that has been detected. All of a sudden, that's paging you at work, right? So creating these functions make it reusable, and creating these dynamic functions make it even more reusable, right? And then making agnostic classes and functions that can be reused across your application becomes really, really important. Because when you reuse it, or you need to modify something, you only have to modify it in one place, right? If I had a function that just looped over 5 elements, but I have another function that loops over 10, another function that loops over 20, when does it stop? Right? The answer doesn't. That's really unmaintainable, so you would never do that.
Mm.
Okay, so there you go. importance of functions, reusability, organizational structure. And this is just they're just giving you an example on calling your function to do something. We went over for each here. A for each loop is just a simple for loop that you can attach to my array, and if you wanted to do something, right? Do we need to see an example of that? We could do that.
Yes.
See an example of it. So let's just do something, and I'm going to pass in just this. This is my argument. I'm going to pass this in. Right, I'm going to save this. Okay. And I have this. And I'm going to do some param dot for each. And then for every element in there, I want to do what? Let me just double it. Element times 2. And then I can just return some param. Let's make this really easy. There we go. What's my output going to be when I run my function?
268.
It's going to be 268.
Yeah.
Let's see. It's not 268. It's 134. Can anyone tell me why?
For each. Is it because you didn't put the parentheses over element in the first element?
No. If it's only one element, it doesn't need parentheses. If it was 2, you would need parentheses. Can someone tell
Don't
me
you
why?
return element? No.
Element's not defined outside of that function. Now, this is a really important thing. Look at line 4. You see line 4 inside of those parentheses on line 4. That's a self-enclosed function. Element, and you're not. I don't know when you get into this, but it's about scoping. It's not within the scope of that return statement.
Oh, I see.
Yeah, the console log would have to have the function in the console log, right? Console log function, like something like that. Or it's
No,
running the function in the console log.
You're not answering my question. This is a properly written function. I just want to know why it's
I
not
get it.
268. We assumed it would be 268. Why is it not 268?
Well, it's not in the function. The console log's not in function. If you
No, this is a properly written function. That's not it. My console log wraps my entire function. I make my function call
Okay.
with do something, and I pass in an argument, and I return something with a function. So this returns something, but why is it not returning 268?
Okay.
Because the
You're not updating, well, you're not pushing it to the array. You're just returning the original one.
I'm only returning the original one. Yeah, that's it. This value, this computation is happening, but it's not being captured anywhere. Right? This is not being captured anywhere at all. Right? But if I had let's do let total equal 0, and let's say in here I did an element plus equals total. Actually, I would have to be total first, I believe. Total plus equals element, and I return total. Well, what will be the answer? If I run this function, what do I get?
Right now, it still should be 134 because you're just adding 0.
Is it?
Total equals 0, right?
Total equals 0. Correct.
0 plus equals the element.
Oh, it's adding all of the
Oh, it
elements
adds
together.
each time. Oh, yeah.
So you're getting 8.
Yeah. You get 8. So the function here did run, right? The problem earlier is it wasn't being captured anywhere, but if I choose to capture that value outside of that function and give it some kind of variable that it can be reassigned to, right? It will capture that value. So this is a loop. right? But you have to be mindful. This is not like map. Map creates its own list, right? And then you can return it, right? But this is
Mhm.
just a simple loop. So there you go. For each.
Okay.
Understanding how to use these, I think is important. I think it's pretty straightforward after you practice it for a little bit. But again, just syntactical sugar. There's nothing you can do with these fancy loops that you can do with a normal for loop. If you feel comfortable with just a normal for loop, just to stick with that until you get more practice, and you're going to be just fine.
Mhm.
Just fancy loops. Just exposure here, I think it's important. Okay, I did that. This is just an example. This is just printing stuff.
Mhm.
This is actually a pretty important use case here. So if we actually give a const value to my R for each print message and we return value, it shows undefined. And this is the reason why. We just kind of explained why this happens. So if you did this, it would be undefined. And it would be undefined why again?
There's nothing of value being defined.
Yeah. Remember, it's executing the function, but the value is not being captured anywhere. So when you try to capture nothing in a value, it comes back nothing, undefined. Subtle differences in the way that you use some of these high order functions. Again, just exposing you to it.
Gabriel, would you mind giving an example fixing that undefined, like actually creating a variable for it to catch or to capture?
Yeah, we just did it here.
Yep. So
And
a new variable, right?
the issue with this, it's you're not catching anything in here. You're doing something to my array, right? And then you're trying to assign it, right? But nothing in here has been captured. Or look at this one. I've captured it outside of the scope of this function here. So even if this line 5 executes and goes away, guess what? I just saved it here. So when I return, there's a value there, something that this isn't doing. Let me give you this example for in just 1 second. So we're here. Very common use case with new programmers is look at line 27. They will try to do something here, either console log on line 28 or write some code here. And then they will try to return outside of the loop, return something, right? But what the code that they write on line 29 never captures the execution of whatever they're trying to do. So what happens when the loop ends? What happens to all the code that ran inside the loop? What happens when this loop ends?
It disappears.
Disappears. Yeah. You need to capture it, right? Because this code only exists within the context of the loop. When the loop ends, it goes away. So you should have captured it outside of the loop, right? In an array, in a dictionary, in a count, in something, right? Another common thing I see is they'll do this. What's wrong with line 28?
I mean, some var is only going to be you're only going to be able to access it within that for loop. It's only within that scope of that for loop. So outside of it, you're not going to be able to reference it or utilize it.
That is correct. And what's going to happen on every iteration?
It's going to change.
It's not going to change. It's going to what? Well, it's going to change kind of.
It's going to reset.
Reinitialize is the word
Yeah.
you're looking for. But
Mhm.
yes, right? On
Yeah.
every iteration, it reinitializes because it loops, it initializes,
Mhm.
runs some other stuff inside the loop. But the minute it hits the next iteration, it's running to the top of that loop again, right?
Mhm.
It was on 0, now it's on 1. Now it's reinitializing some bar to whatever you initialized it again. Is that what you want? Rarely that's what you want. That's very rarely is that what you want. Typically it points to a mistake. Now there are use cases for this, but they're rare. And typically there's a better way to do it.
Mhm.
Make sense?
Mhm.
Alrighty. So we talked about this right here, the for each. We talked about map. Map basically does the same thing as for each, except that returns a new array. This is a really important concept, the difference between map and for each. Map creates its own new array. So let's go ahead and do this. This is just a function called double. And this is the test case here. It says const myr map double, const return value. What's this going to output? If I run this, what's this going to output?
Should be undefined because nothing is being defined, is it?
Let's see. Help us out there, Adam.
Okay, so it errored. Um, and what does it say down here? Oh, my array is not defined. Oh yeah, because it's um const return value. It's trying to assign that variable with my array dot map double, but my array dot map is not assigned to anything.
Okay. Does this fix it?
It should, yes.
Let's see. There you go. Explain to me what's happening on line 9. There's a lot going on here. It's not as straightforward as it seems.
Uh, return value is being defined by your previous variable, my array, and it's doubling it, multiplying. It's what's going through the array and adding itself to each instance. Did you try that with
Close,
this too?
close. That's pretty close. So return value is just where it's saved, right? It's grabbing my array here, right? It's applying the function map. Okay, so it's going to create a new array. And what's it doing to every single element? It's applying this function. Now, that may look weird, right? Because if this was so this is exactly the same. If I run this, I get the same, right? Yeah. I just created an outside function and I passed it into my map function as a parameter, but I could have easily just as well created it. Right? That's just an arrow function. A slimmed down version of an arrow function. Boop, 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 boop. You could even const, what is it? What do they call it? Double element. What is it? Is this the same? If I run it again, do I get the same thing? Yeah. 3 different ways to do the exact same thing. If you just understand the concept, then you can mix and match however you want. Does line 7 look super high speed? Yes. But the technical implementation doesn't really change under the hood. It's not any more optimal. Yes? All right, so there we go. That's map. Filter. This is just an implementation of filter. What does filter do? Does anyone know?
It's like map in the way it like spits out a new array, but it's only going to spit out the certain values that you tell it to look for.
Okay. Keep that in mind. Let's run this and see if this works like it's supposed to. Oh, sorry about that. I gotta, what is it? By. This is just even numbers, right? 3, 4, 5, 6, 7. That's good enough. Okay, let's run this. That's going to be what, 6? Let's run this. I got 2, 4, 6. Okay. Cool. Does it create a new array though?
Doesn't it have to? Doesn't it create a new array and then add the new values into it?
Not quite. So that's an important difference between map and filter. Map does what? It creates a new array. Filter will edit the array that it's applied on, right? If I do this, now return my array here. What value am I going to get? Anyone know?
Well, based on what you just said, I'm assuming it's going to do the same thing as the 246.
Is it?
If
I
I
didn't have
understood
it.
what you said, but so it doesn't actually change it. It just changes it during the moment you're writing it for that like on the filter part, but it's not actually changing the original.
Yeah, very good.
So it's good that
Right.
you said that because I wasn't clear either way. So
It's altering it at the moment. That's very different than what map does, because map creates a new one, right? Filter alters the input array at the moment that it executes. So keep that in mind. Here, this value isn't captured, right? But if you captured it like the code was earlier, then that would be an altered version of the array. Just keep that in mind. Slight differences. But filter is really just a for loop, right? What's happening? For a for loop, it would just be what?
A console log.
What do you mean?
Well,
What?
well, when you're printing out something, it prints it out for whatever expression you have in the console log at that moment. So it's not really changing anything within it. It's just, it's showing you what your results would be in real time. I don't know how to.
Yeah, when the function executes.
Right.
But this filter, if I just wanted to do a normal loop, what does this look like? I use filter here, a high order
Yeah.
function.
Mhm.
You're essentially you're doing your for loop, then on the if statement, you're gonna only show the ones that are even, essentially from the my array. So
Yeah,
as it
it'd
iterates
be,
through each one, it will skip. Yeah, it'll do that same thing as the function did.
and I would
Yeah.
do something like result push my R brackets I, right? And oh, here I'd have something like what? Like, I don't know, result
Mhm.
equals empty or something, and then I create a new one,
Yeah.
right? Now, this is pretty close to a filter version, right? If I really wanted to be identical almost, I would have to slice my array. I'm not going to get into that right now, but you could.
Mhm.
But this just creates a new one and just gives me a new version with, all the evens or all the odds or whatever it is that you wanted. But it's just you could do it with this loop as well.
Yeah.
Easy.
Could I ask a question about the function you just wrote? So the
Uh,
symbol
the
before
loop I
two,
just wrote, you
the
mean?
the loop. Yeah, sorry, the
Yes.
function's up top. The symbol before the two in the if statement, I thought that showed the remainder after a calculation.
This is a calculation.
Mhm.
What is? Oh yeah, never mind.
Mhm.
My R would be an integer, right? Yeah. And then reduce. This is the old school way of doing it. Oh, no, I'm not going to delete my R this time.
Mhm.
Oh, it's already there. So I guess I could have deleted it. So it's just, hey, this list of 1, 2, 3, 4, you have the total sum. Notice outside of the loop, and here you're plus equaling, that just means you're adding and reassigning in the same step. And then you console log the sum and you have 10, right? But that's just the old school way of doing just to reduce. You could, by the same token, is comment this out, and then you could do a simple my R dot reduce. And then what do you want to do? Typically you see A and B a lot. But it could be, I think one of them is like current, and then the other one's accumulator. I think if you look at the docs or something like that, I don't know. You always see A, B. And here you could just do A plus B,
Mhm.
right? And you could just do the total, right? Now you can just, suppose I could just done sum and I didn't have to redo it. You run it, and same idea. Right, but this is just an arrow function, right? This is really not any different than what they have here. This right here is the way that they did it, but I'm just showing you that it doesn't make a difference for now. Now, when you get to your job, they'll have specific SOPs and they'll have like linting built into your repo where if your spacing isn't right and everything isn't formatted properly, like you'll try to do a PR and it'll be rejected. It'll be like, hey, fix all these things, and then you have to format it just right, and then you push it, and then finally it accepts your PR. So you'll be forced to accommodate to whatever SOP your company has. Make sense? So both of these doing the exact same thing. This giant function here is really just this right here, just in arrow function form. So there you go. Some other programming languages reduce is called fold. I have never heard of this. That may be true. I've never heard of that. But yeah, easy way to remember reduce is it reduces everything to a single number. Actually, I shouldn't say number. That's a lie. You could use reduce on strings if you knew how. So that's not. It reduces it to one item typically. It doesn't necessarily have to be an integer. It could be a string. You see this a lot sometimes, right? If you ever look at like on Code Wars, like one-line solutions, they'll use a lot of built-in methods, right? Oh, sorry about that. I think you had what does this do? Read that for me.
You're defining a unchangeable variable return value, and you are making it or assigning it the value of my array using the filter function on that. And then dot map is a for loop? You said. Never mind, I
What
confused myself.
what's the catch here? Every single one of these things is a what?
Uh,
It does something, but it's also kind of what you hinted at just now. They're all what?
Oops.
Yeah,
oh,
they're
they're
all
all
loops. They're all loops. Filter, it's tagging every element and saying, hey, do you match my criteria? No, get out. Map is doing, hey, I'm going to tag every element and double it or divide it or add it to a string or do whatever to it. And reduce is also tagging every single element, right? And adding it or doing whatever to it. All these are loops under the hood, all of them. So these are 3 consecutive loops. It's tagging my array. It's tagging every element. It's filtering by is even, right? So it's filtering that list by only even numbers. Then it's doubling the even numbers and then adding all the even numbers and then returning a total. That's it. It's returning a total of all even numbers added together in the array by R. That's it. Questions about that? You can string them together. That's what they did. And I think one of your palindrome, this is from yesterday. This is like a classic example where you can do that. They'll they'll give you the coding challenge palindrome, and they'll ask you, they'll be like, let some word equal evil olive, right? And then let some other word equal equal hello. And they'll ask you if it's a palindrome, right? They'll ask you, hey, write a function that tells me if that specific word is a palindrome. It's easy, right? It's just const is palindrome. And then what do you want to do? Well, I'm going to take some word. Then I can just split it, right, by character. Then it's an array, so you can apply an array method to it. So you can reverse it, right? Then you can join it back together on a character, right? And then you can compare it. And then you can compare it to what? to itself. You can console log if that word is a palindrome. So if I run this, some word is a palindrome. See voila. True. But if I did some other word, this is not a palindrome. Some other word. Is that right? Yep. That is not a palindrome, so this should be false. There you go. I took it a step further and did the comparisons in there, right? Because ultimately this all breaks down to just a string, right? So this is effectively just a reverse version of this compared to the variable, which is hold a Boolean, the answer. Questions?
Actually, yeah, so the dot map and dot filter, those were those called high value functions?
High order functions.
High order
But
functions.
yeah, but it's not just that one. Filter, reduce, map, for each, they're all high order functions, which is kind
And
of misleading, but it's just, yeah, just the name for it.
are they apply across Java and Python?
JavaScript has its own high order functions, but they're not that different from what Python has.
Yep.
Right. If I wanted to map something in JavaScript, it'd be the equivalent of like list comprehension in Python. Sorry, I don't write much Python anymore, but it'd be something like anybody know the Python syntax? It'd be like x of x for num in long list or something, whatever the case may be. It's called list comprehension. And it'd be like sum list. Right? You can look into it. Did you guys cover it yesterday or no? But yeah, it'd be list comprehension. There'd be some version of this, but this is effectively creating a new list based on certain criteria. For every element, tag every element, and if it doesn't meet this criteria, then get rid of it. So it'd be just like the map version. The syntax is slightly different, but almost every language has high order functions, and they typically tend to be more recent. And the syntax is cleaner. But again, really main thing that you need to get from this is it's a nice to know, but it's not a must know. It's nice to know because when you're reading other people's code, you don't want to be looking at everything, you know. And I think that's one thing that's missed a lot when people are learning a program. I have a lot of students tell me, "Oh, why do I have to know this if I can just look it up?" And that's honestly one of the things that triggers me to no end because they haven't been at that. You don't understand that when you're there and nothing is working, and you have to look up every single thing because you don't know it, you're going to have 200 tabs open and not know what's going on. There isn't enough hours in the day that are going to save your time. You can't look everything up. No one's going to wait for you. We need a solution yesterday. I'm sure you've seen Jordan sometimes jump in here or jump out, or you haven't seen it too much, but sometimes he'll be on call or something and something breaks and you'll be late to class. That's going to happen. That's real because we need it right now. No, you can't leave. You need to fix this. Production's down or something's on fire. Right? Maybe it hasn't happened in this class because you guys are pretty new, but that will happen. Not uncommon. And in those moments, it really does pay to know your stuff, right? Know how to solve this, or literally you're driving home and debug something over the phone with someone because you're not near your laptop. Make sense? Any questions about high order functions before we hit a break? No questions? Alrighty. The one that's going to use, well, you could use high order functions for is that I know for sure is Armstrong numbers is one of your challenges. I would actually probably tackle that one first. I'm not saying it's the easiest, but that's the one where you can make use of these high order functions. It's just syntactical sugar, high speed, just text that looks nice and is shorter, easier to read for a lot of people. If I use like a for each loop, I know what it's doing, as opposed to looking for 3 lines of a normal for loop. So it is nice, but just know you don't absolutely need it if you know your basic for loops over and over and over again. Any last minute questions before we go on break, guys? Alrighty.
Just
So
out of
what's gonna,
curiosity,
yeah,
if you were given these 3 challenges, how long would it take you to complete those 3 challenges that we have today?
I think that's an unfair question for me.
Well, I want to see how, if I get to your level, like how fast could I do
Like 10 minutes for all 3.
it? Nice.
But it's not good to compare yourself to other people. Sometimes I compare myself with like 27-year-olds at my job. They're way better than I am. But they have 5 years experience. I have 3. That's okay. All right, guys. So it's 6:34. Please take a 11-minute break. We'll be back at 6:45 and I'll open the breakout rooms. Jump into your own breakout rooms. And I'll probably let you go for maybe 30, 40 minutes and then bring you in. And then we'll discuss, actually tackle Armstrong numbers first, because when I bring you back in, we'll do Armstrong numbers first. Make sense? All right, break. So this is Armstrong numbers, and I always like to look at the test file and run it to make sure that it is running. So if I run my test file here, I'm getting a bunch of falses. Good. That means that my installation went okay and it's running the test file. So when I look at it, what's happening? What's being passed to my function? What's being passed to my function? This is important because when I go to the Armstrong numbers JS file, it's going to help me kind of write it.
Cisco, your mic's not working.
My mic's not working?
No,
Yeah,
no, no. Cisco's mic goes out.
Oh, okay.
Can you hear me now?
Yeah, I can hear you.
Okay. Yeah, it looks like so you're creating an array of numbers, and it's taking those, it's populating the array with the amount of numbers that's given. So the first one is populating an array of 8 numbers, and then it's going to send it through the find Armstrong numbers, and the find Armstrong numbers is going to run its calculations on it, and whatever the return, it's going to return another array, hopefully with the numbers that are Armstrong numbers matching what's on the far right hand side of that.
Yeah, that's it. Look at the 4 tests. What's being passed to your function, this is what's being just an array of varying length from 0 to 999, right? And it's being tested against that second one, right? So it says array equals is comparing this first part to the second part. And by looking at this, some crucial information is given to us here. We notice that all the numbers up to 9 are all Armstrong numbers. So keep that in mind when you go to write your function. Okay, cool. So I'm going to be tested on these. They're failing right now. So my goal is to get them to pass. Okay, so when I look at my function, I just put this return right here to make sure everything was working. But here, what's my parameter being passed in my function? What goes in here on line 3?
It should be well, it should be a number.
And not a number.
Oh, an array, yeah. Be an array.
An array of numbers. And that could be an array with 1 element in 0 up to 999 elements, right? Okay, so we know we're getting a list and an array of numbers. So here we go. How do we pseudocode this? What's the first thing I want to check?
Well, you want to check that you're getting that array back for one thing. I think that's the
You can just assume you're getting an array back.
oh, okay.
Think about this. This is not that easy. What's the first thing you need to check here? This is where everyone is right now, right? Yes?
Mhm.
Everyone start with Armstrong numbers. All right, so everyone should be here now.
All right.
Okay, what do you check here on line 4? We can pseudocode this here, and then I can cut you loose again. What's the first thing you need to check? You got this information from your test case.
Let's see.
Are you talking about testing if the argument is being passed through the parameter? Right there, just seeing if it runs with anything.
No. Just assume that you're going to get a list of numbers. Look at this. What does this tell us right here?
If the number is less than 10, it's going to be true.
Yeah. Right. So array of numbers, right? We know that these numbers are coming in order from 0 to X or 0 to 999. So we know, right? If length is less than what?
Less than 10.
Less than 10, push to result array automatically. Because they're all Armstrong numbers. We don't have to start checking until the number's 10 or bigger, right?
I see. Mm-hmm.
You can start checking if integer is an Armstrong number. If equal or bigger than 10. And I know you looked at the test cases. There are no 2-digit Armstrong numbers. There are only 3-digit. But for this use test case, we're going to assume we don't know that. Okay?
All right.
So here we go. So now, if it's less than 10, we're going to automatically push because they're all Armstrong numbers, right? Because it's 1 to 9 to the first power. Cool. But now if there are 2 integers, what are we going to do? How do we pseudocode this?
If there are 2 integers, we basically want to if there are 2 integers, we basically want to really we don't want to return anything. So I guess can we just pass or continue?
We could, but there's a better way to do that. If it's equal to 10 or bigger than 10, what do we need to start doing?
Equal to 10 or bigger than 10, what do we need to start doing?
Multiplying.
Yeah, we need to start multiplying. Well, taking them to the power of, but the power of is just multiplying, right? Yeah, so how do we do that? What's the pseudocode here? If the number is bigger than 10, we need to start doing a bunch of things. What do we need to do here?
We need to loop through the numbers by that power. So we need to loop through each number in that whole integer, or each integer in that whole number.
Okay. So this is an important thing here. So if if number greater than or equal to 10,
Mhm.
right? We need to, there needs to be something, right? We need to be looping here, right? So actually the loop goes in here almost, right? You can do this a couple different ways, but here we need a loop, right? We need to loop. And what are we going to check inside the loop? Or what are we going to do inside of the loop?
Well, what we want to do is we want to take the value and multiply it or do the power of however many digits that number has in it.
Yeah,
So
but
for that
that's a giant chunk. You need to break that up into at least 3 or 4 different steps.
okay.
It may be overcomplicating it, but if we're starting with an integer, would you need to turn it into a string so you could separate
Yeah,
the different? All
you're
right.
going to have to do something like this. So we know that our length, well, integers don't have length. They don't have the property length,
Right.
right? So you're almost going to have to cast. It's going to be some version of this. Cast integer to string. Then you're going to have to split it, right?
Mhm.
You're going to have to split it. Then what I would do is I would map it, casting to integer again, right? Now you have a list of integers, right? And then mapping them again into their powers, mapping again and into their powers, right?
Mhm.
And what's the next thing you need to do?
You got to interesting. You got to turn it back into a you need to add them together,
Join them, not
join
add
them.
them
Yeah.
together because that's arithmetic, right? So you
Yeah.
pretty much have to undo what you just did. So you cast them into the string, you split them, you map them into integers, you take them to their respective power, right? Then you
Mhm.
turn them into strings again, then join them, then cast them as an integer and see if it equals the original number.
Mhm.
If above is true, push the results array. Return results array. Roughly what it should look like. So this is a lot, right? Especially these middle steps. And this loop can go right at the beginning, or if we can assume, and for this sake, let's assume that we're going to get them all in order, right?
Mhm.
If that number is less than that, you could actually just return the array that's passed into the function if it's less than 10, right? Because we know that the numbers are going to be 0 through 9, and all of those are Armstrong numbers. So that's what I would do. If the length is less than 10, you don't even have to push the results array, right? If less than 10, return early, return param passed in early, because we know they're all Armstrong numbers, right? And then your loop can start after that, right? You could do a loop right at the beginning and have some kind of check if it's less than this, send it. But I think this way is probably slightly cleaner. But there you go. Questions about this pseudocode? How I would do this, right? You see that first one says cast integer to a string
Yep.
and then split it. It says split it here. What I would do is take it step by step. Inside that loop, it says cast integer to a string. You're going to have, right? You can give it whatever variable name you want, right? You can call it integer as string, and then you can cast it. I think it's string in JavaScript, string, and then whatever number or whatever element you're on, right? And on the very next line, right? Even if you have to have 4 or 5 variables inside that loop, as long as you know what's happening in every step and comment it out, right? And then so you're going to have something like this integer as string, right? You're just casting it. And then the very next line is going to be, look at our pseudocode, it says split into split it and map it. You could make that another one. You could just say, give me another variable name, string num array, and then you can have integer as string dot split by character. Right? I just took care of this. Split it and then map it. That could even be another line. Right? Now take it. So now this is going to be string num array. This can be num array, right? And here you're going to take string num array, and you're going to map it, right? You're going to do every element. I need it as an integer now. Okay. So that's number. That's one way to do it. You can do %, right? Element. And you slowly break it down. You see how I did that?
Yeah.
Don't worry about having too many variables. Right now, it's really important that you kind of see the process and see the step. That's why when I think Cisco was taught, he mentioned something, but he lumped together like 4 of the biggest steps into one statement, right? You can't, programming is not going to work that way. You need to really parse it down to very small pieces, right? And that's what we're attempting to do here. Any questions about how you're going to attack this? This is not the easiest problem to start with. I don't know if that was the best idea to start with this one, but this one definitely does teach you, hey, break this down piece by piece. Make sense?
Mhm.
All right.
Yeah.
Give it a shot, guys. All right, guys. How did we do? How far we get on Armstrong? Anyone finish by chance?
Well, I got close. I was just running my last test, hopefully to pass all the tests. Yeah, let's see here. Oh, that's what I was looking for. Yeah, I got all the way down to the pretty much doing the sum of the numbers, and I'm running this test right now. Let's see what happens here. Meet the array.
Anyone else?
I didn't make it quite all the way through, but I tell you, I got a lot further than I think I would have, because you gave us that skeleton. So I need a little bit more time, but I think I can finish it.
All righty, guys. No worries. We're going to go ahead and go over it right now, and then I'll give you a head start on the next one, which is hacker text, I believe. Hacker text we probably should have done first. It's a little easier, but that's okay. It's not that big of a deal. Share. Can everyone see my screen?
Yep.
Yes.
Yes.
All right. And the way that I solved it is exactly using all the pseudocode that we discussed earlier. Let's walk through it. Very, very simple, straight up. I actually ended up making just a results array at the beginning instead of skipping the first 9. I had that earlier, but this looked cleaner, so I just deleted it. So here we go. Had you done it the other way that we were discussing, you would have just started your loop at number 10, right? and returned early when length is less than 10. So that's what I had earlier, but I deleted it. You could have done that easily, but I thought this was cleaner, so I just went with this. So this is just, look at this, just a normal loop. So what did I do? I said, okay, what is array of numbers brackets I? It's just a number. That's all it is. Give it a number, right? But I know that I need it as a string, right? So I casted it as a string, right? And I also knew that I was going to need the length of that string, right? So I gave me the length of the num string right here, straight up. Everyone tracking so far, right?
Yeah.
So I've just gotten the length and I've casted my integer into a string. That's it. Then I did exactly what I said I was going to do. String num array, and I split that string, right? So that number 11 now becomes a list of two strings, 1, 1, right? And then I did that heavy lifting. This right here could easily be another variable right here. I just threw it in one just cause, but this could easily be two. Why could it be two? This could be one, right?
Mm-hmm.
And this can be two. I just string together two consecutive math functions. You could string together 3 consecutive math, 10 consecutive math functions, and throw a filter there at the end or a reduce. There's no limit, right? But I thought that this was cleaner. So what I did here, just walking through it, right, is string num array, string num array. It's an array of string numbers, right? What's the first thing that I do? I just cast them to integers. So now I have a list of integers. And what do? I just take the power of it. Asterisk, asterisk in JavaScript, it's to the power of. One is just multiplication, but 2 is to the power of. I'm sure if you probably went to W3 schools or whatever, they probably had like a math POW, I think. Yeah, math POW. You could have done that. But I try not to use libraries whenever I don't need to, because it helps my coding to be able just to do it straight up. And you're gonna come to realize once you get into tech that when you start importing libraries and you start dealing with like dependency trees, it starts getting really, really messy because they'll conflict with one another. Like, on this specific library, you can use version 1.37, right? But that one sometimes won't mesh with another package that can only use up to version 1.36. So now you need to like change some of the dependencies so they all work together nicely. So I always try to import as few libraries as possible a lot of the time, depending on exactly what I'm dealing with. Anyway, so here we go. It's just asterisk asterisk to the power. And this gives me, what does this give me at the end? Num array is what?
Num array, it's that gives you the final array total, all the elements totaled in the array for that.
Yeah, it gives me the total of every element in the array in a list. So the only thing I have to do is here add it. That's what I do with the reduce. If you're wondering what the 0 is, it says it's typically not going to error out if you don't include a 0, but it's a good practice to say, hey, start from 0. That's what that's saying. So then I have all my numbers in this array, and I just have to add them up, right? So that's what I do. I add them all up, and I get a result number, and then I compare the result number to number. And what is number? My current iteration right there on line 7. And I simply, if it's equal, that means it's an Armstrong number. Push it to the result array. I wait till the loop ends. I return everything that's in the result array. If you try to use Grok or ChatGPT or Gemini or something, you're going to come to realize that probably none of them gave you this. You can try it right now if you want. They're not going to give you this answer. Why is that? But maybe they think there's better ways to do it. Not for a beginner, there isn't. Because this walks you through step by step what you needed to do. And this follows almost identical the code that we wrote earlier.
Right.
Questions about this?
It's close to where I was. This close to where I was. I had far too many variables I was starting out with, though.
Oh, that's never necessarily a wrong thing, right? When in doubt, always declare a new variable. I think the mistake happens, I think, a lot of the time where they don't declare enough variables and they get lost in their own code. You kind of get lost with what you're dealing with, right?
Yeah. Yeah. You know, yeah. Python, I was actually able to solve it in Python, but when it came to JavaScript, yeah, it proved to be a little bit more difficult for me than
Yeah, the concepts are the same, just maybe the syntax would have been a little different.
yeah.
Any other questions about this or any of the high order functions as long as we're on this challenge right now? Any of the high order function questions or on this challenge?
Yeah, Guillermo, you did mention that we were going to be joining the string. Is there a portion of this that joins without using the dot join?
No, actually, I made a mistake on that one. You don't have to join it back necessarily, right? What I meant to say, I misspoke earlier. You just add the numbers together. I said join, but I misspoke. Because you just have to add all the numbers together and see if it equals. If 371, all the powers of those individual numbers added together equal 371. So there's no need to join them back together.
Now you know I'm paying attention.
Yeah. And actually, when I was writing this, I ran into that same problem because I was following the pseudocode and I was like, I have to join it. And I kept failing the last two test cases. I was like, that doesn't make sense. And I looked at it and I was like, oh, wait, yeah, I just meant to add.
Now I got a question. So I noticed you initialized all your variables inside the for loop. What if you had actually started it outside of the for loop and then just, um, modified it within the loop? Like you have the result array outside. What if you had const number, const integer, string, so on and so forth. Just those.
Would they be not initialized at the beginning?
Right.
I mean, I could do that, but it makes no sense to do that simply because all those variables only make sense within the context of the loop. I need them inside of this loop. So ultimately, I can just get down to line 15.
Right.
That's the reason for all of this code. Once this loop stops, none of it matters to me anymore. It can go away. I have captured effectively everything I needed on line 4, and I just return it on line 18. So all this logic only matters inside of the for loop. Anything that I want, I've captured it outside of the for loop. So if it ends and I capture nothing else in there, it doesn't matter. I didn't need it. Yeah, I don't need the other, 900 plus numbers. I just needed the Armstrong numbers.
Gotcha.
Okay, good stuff. I downloaded hacker text here, so I kind of want to get you started on this. So we'll look at hacker text here. Let's look at the README. Okay, it says write a simple function that converts a string into hacker text. For our purposes, hacker text means every other letter should be capitalized. The letter E should be replaced with a number 3. A's should be removed. For example, the input hacker text should return hacker text. Let's look at this. I'm going to actually just copy this. I'm going to go into hacker text. I'm just going to drop this here so I don't have to keep flipping back. Okay. Okay, cool. So this is hacker text. What's the first thing we want to do here?
a for loop.
Yeah, all right, let's look at it. All right, so this is our little function here, right? And we can, I could just do a console log here and just run this file individually, right? So this is called hacker text, right? And I'm going to pass in, this is my test case here. It's just a string called hacker text. And I know that this answer should be hacker text. Cool. So we know that we are going to need some kind of loop, right? So we're going to need to loop. Then what?
You're going to check. You can check and see if the letter is, well, if the letter is basically equal, negative or positive, so you can do the every other letter thing.
Okay. You kind of got yourself mixed up there, but I know what you're talking about.
Yeah.
All right.
Yeah. You want to check for every other letter.
Check for every other letter within the loop and capitalize.
Right.
Capitalize. It says every other letter, so we can do even or odd. Pick one.
Mhm.
Capitalize odd numbers. How about that? There you go. Check every other letter within the loop and just capitalize odd numbers. Okay, and that's going to be a simple what? 2 uppercase, right? 2 uppercase in JavaScript. and Python, it would be just dot upper, right?
Right. Yeah.
Boom. All right, so we're going to do that. Then what are we going to do?
Change the e's to 3.
Okay, if the letter is equal to E, change it to 3. Cool. Then what?
Did you do another if statement to remove the A's?
If current iteration is a letter A, do what?
Remove it.
Remove it. Okay, this is getting a little messy. You can do this all in one loop, but you're going to have to be careful. An easier way, albeit slightly cumbersome, is just to do 3 loops. Do 3 loops. What does the first loop do?
The first one, we should capitalize every other letter.
Capitalize every other letter. The second loop does what? If letter equal to E, change
Remove.
to 3. And then the last one would be remove A's from string.
Mhm.
Right? The last line here says remove A's from string. You can't actually remove the letter A from string. So what are you going to have to do instead?
Replace it with.
Yeah, even the JavaScript method replace, right, is a
Mhm.
misnomer because you can't replace a letter in a string. You can only do what?
Write a new one.
Yeah, recreate the string.
Mhm.
Right. To replace there is a bad name for that. Can't replace a letter in a string because strings are what?
Immutable.
Immutable. You must recreate it without the letter A.
Right.
Right. So replace really should be more or less like recreate or something like that. I don't know. I think the JavaScript heads can think of better names than that. Right. So that's what's happening. So keep this in mind. I would actually try to do it this way first. And if you have time, do it the other way. This is much easier. Doing 3 loops. So you're going to have kind of a long function with 3 loops, but every loop is going to be in charge of something. right? And ultimately, what this is going to entail is some kind of string, right? Some kind of some variable at the top of the function, right? That's going to look something like this. Let result string equal an empty string, and then you're going to do what to it as you loop.
Whatever at the top of function you're gonna do.
You're going to concatenate to it, right?
Oh, okay, yeah.
To that string. Right? What if let result, instead of result string, result array equals this, just an empty array, and then I can just push to the new array and then just join it at the end, right? Join before returning, or actually I should even join on the return statement. We can do that. Both of those would work, right?
Yeah.
Push every letter to an array and then join it as you return it, or join it before you return it. That both would do the same thing, right? Yes? Okay. So here's kind of a somewhat tricky question. Which of these is more optimal? You have the option of doing either. Which one's better, objectively speaking?
The concatenating of the string, I think.
No, don't say I think. There is no I think and there's no sometimes in engineering. And that is also wrong. It's the other one, but can anyone tell me why? We've talked about it before. We just mentioned it earlier a little bit. We kind of walked around this really important idea in programming. One is definitely better.
Is it that the actual syntax of making it would be shorter?
No, very rarely is that ever going to be the answer. Things being shorter is never really going to be a deciding factor in anything, really, right? Almost everything, efficiency is going to trump everything, and then readability will probably be a close second. Shortness of syntax rarely gets that much attention paid to it.
Mm,
Well, if I were to guess, I would say it simplifies things because what you previously stated that the original two, which is the loop and the if, that was a little bit too cumbersome. So to simplify it, I think the one that the cursor is flicking on and off, that would be a simplified version or the easier version for us to do. Because it's never about what is complex, but what it is that we can get things done efficiently, I think.
Yeah, I told you to do this one first, but I'm not asking about that. I'm asking this. Which one's better? Out of these two options, which one's better? And Cisco already said, well, this one. And I told him, no, that's not right. The answer is this one. But can anyone tell me why?
Well, we talked a little bit about being able to reuse objects. So maybe
No,
no.
no. We talked about it. You can't replace, right? You can't replace.
oh,
So
yeah,
what's the answer?
I see. Yeah,
So what's the answer?
the array would be better because you have more functionality with the array as far as what you can do to it, whether you want to add, remove,
No, that's not the reason.
no, okay.
All right. You guys are struggling. That's okay. Here's the answer. On every iteration, what happens to this variable on line 5?
It's turned into a string? No.
Yeah, but we already know that. What's happening on every iteration? If I have a loop, I have all these loops, depending on which one you do. Right. And every
Oh,
loop, what's happening here?
okay. I wasn't thinking about that being inside of the loop. So it's being it's starting over again or zeroing out every time you go through the loop.
Yeah, but that doesn't answer my question. What's happening to this string on every iteration if you concatenate to it as opposed to push to it? It's being recreated on every iteration.
Okay.
This you push to it. It's already allocated memory. So you push to it and you join it. That's one action. Here you're effectively erasing the string every time. If the string is 1,000,000 characters long, you've created and erased the string 1,000,000 times.
Mm.
Here, you've added to it, but you've only joined it once. Right, so this is the more optimal solution.
Okay.
Not subjectively speaking, but objectively speaking. Right?
Okay.
That gets a little bit deeper than we need to right now, but there is a difference. Remember I said in programming, there's no same,
Mm-hmm.
right? Because the new program is so nuanced, right? And honestly, JavaScript and Python are probably the easiest two languages, honestly. Everything else just gets way more complicated. Um, they're both dynamic, they're both pretty easy to understand, right? Everything else is harder. So these small nuances, with a little bit more time, you'll get to understand. So there you go. That's how you solve this. I would do it with 3 loops first. And then if you can condense it, you really only need 1 loop. You can do it. Now, has everyone seen the replace method before? You'll have like let some string equals dog, and then they'll say some string replace, D with A. Have you guys seen that?
I believe so.
Okay. What is this right here? What is replace under the hood?
Another loop?
Yep. There you go. Everything in programming is just a loop. Replace is just a loop. It's tagging every element. Are you D? 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 Oh, you are D. Cool. We're going to recreate the string without you. And instead of you, we're going to add an A. And you could chain replace together too. You can replace O with Z. And what is replace? Just another loop. When this function stops, this one begins. And then I can replace it again. Replace, I'm kind of out of letters. I should have with X. There you go. When this function stops, this one begins. And just another linear switch. And now you're thinking, hey, is it recreating the string 3 times? Yes, it is. Questions about how to tackle hacker text. All right, I'm going to give you about 25 minutes and we'll come wrap up around 9:20-ish. Okay?
All right.
Great. Let me open the rooms. They're open. All right, guys, how did hacker text go?
Went
Did we get
well.
it? We got it?
Yeah, I got it.
Did we get it with 3 loops?
No. I I actually I implemented a higher order function and everything in mind, and I just used I used 1 loop. Here you go. I use 1 loop and inside of one function, and then if else statements in the other one.
Alrighty, good. We're going to show a version of that here in a second. Did anybody do 3 loops by chance? Anybody else do high order functions and get it that way? Okay, let me show you real quick. I drew up both of them real quick. So hopefully when you guys feel more comfortable, it's typically normal from around here for me not to share as much and for you guys to share your answers. That's okay if you're still getting comfortable with the languages, but just know that going forward, we're going to ask more of that. So here we go. Here's the first example. Can you see my screen?
Yes.
This is just 3 loops that I was talking about. Does it look pretty? No. Does it work? Yes, it does. So when you're solving coding challenges, and even when you're solving problems at work, you want to solve the problem first. I know that seems like rudimentary, but I think sometimes, especially new programmers, get caught up on like the pretty solution than a solution that works. The ugliest solution that works is better than the pretty solution that doesn't. Does that make sense?
Yes.
So keep that in mind. So here we go. Just exactly like we talked about it. 1 loop, capitalize every other letter. And if everything's odd, if the letter is odd, an odd index, I just capitalize it and I concatenate to modified text. Then I do my second loop, right? Notice now I'm looping over modified text. This that was created on line 2, right? Now, if the letter's E, I'm just adding a 3 instead. If not, I'm just adding the same character, nothing fancy. And then the last loop, I'm going to remove the A's, creating another result. This one I'm going to return, so I call it the result. Right now, I'm iterating with text with E, what was created here, right? And if I am concatenating anything that's not an A, because we're supposed to include everything that's not an A, right? So that's what I did there, and I just return result. 3 loops, easy, right? And then you could have done this version, and you run it. It runs true. This is a test case that I have. If hacker text equals hacker text with the 3s and the letters. Straight up. That's one way to do it. And then you could have just done, I mean, you could have even turned this into an arrow function and done it all on a return statement, right? So let's walk through it. I can show you that this works too, true as well. What did I do? I took text, I split it. So now I have an array of strings. An array of strings, now I mapped over it. I mapped over it, and then I grabbed the character in the index. And I said, hey, if the index is odd, right, uppercase it. This is known as a what? Does anyone know? This section right there.
Oh, ternary.
Yeah, this is ternary operator. It's just a fancy if-else statement. So what this is saying is, hey, if this is odd, I want you to uppercase it. And if this Boolean is not true, then just concatenate the char, the normal character without the uppercase. So this is going to effectively uppercase every odd number and then leave alone every even number, which is what this does. Boom. And after that, I join it and then I hit replace, right, on that string. It says, hey, the character E, G stands for global. If you're not familiar with regex, this is what this is. It's just pattern matching. That's okay. It says, hey, look at the letter E globally. That means across the entire string, and replace it with 3. And then I did it again for every letter A, replace it with what? Oh, sorry. Replace it with an empty string, which is nothing. Cool. And then just return all of it. And both do the exact same thing.
Mm-hmm. That's awesome.
And I just want to touch on something that Cisco said, saying, hey, I only did it in 1 loop. What's wrong with that statement, Cisco? Or anyone that can figure out.
All of those functions are effectively loops, so
Yeah. So you didn't do it in 1 loop. It's actually impossible to do this in just 1 loop.
Okay.
Map is a loop. Replaces a loop. Replaces a loop. That's at least 3 loops. That's actually not that different from here. So that's how you solve hacker text. I'm actually your teacher on Thursday as well, and we'll start with this on Thursday. This is the last one we didn't get to, sum pairs. I'm just going to give you the down and dirty. There's 2 ways. Well, there's more than 2 ways, but I'm going to give you the 2 most popular ways to solve it. See if we can figure it out before Thursday. We'll start class with this assignment Thursday. It's called sum pairs. You're going to iterate, surprise, it's another loop, over a list of integers. right? And the second parameter passed in is a total. And you're going to figure out, hey, do any combination, keyword here, any combination of the numbers in this array, do they equal the total given? If they do, return a list with the pairs, right? So the brute force is nested loops. You just check every single number with every other single number and check, do they equal 9? Do they equal 7? Whatever the total is. If they do, you push them to a result array. And you keep doing that until both loops finish. That's one way to do it. The optimal solution here is using a dictionary and pushing every single number as you iterate into the dictionary, and then cross-checking if the current iteration that you're on and the number already in the dictionary equal that, creating a list and sending it somewhere to hold. That's the optimal solution. Both will work. Your inclination initially will be nested loops, do it that way, but if you can figure out how to do it with a dictionary, that is the optimal solution. This is actually a very popular interview question. So that's how you solve it. I didn't really give you any pseudocode, but I kind of give you the broad strokes idea on how you solve that problem. We'll start with that on Thursday. Any last minute questions for the good of the group?
Yeah, Gabriel, how soon will this lecture be on the YouTube channel?
By the end of tonight, I'll make sure to upload it this time. I typically upload it like the next day. I don't know if you've noticed that, but I will upload that right after we're done here. So it should be good to go by tomorrow morning. Sometimes it takes like 40 minutes to buffer or something like that, or whatever YouTube does.
Okay.
Questions?
I got a quick question. So I noticed in your last solution, you used const, and inside of your for loop, what would be the difference of using a const versus let for initializing your variables inside of a for loop? Is there any?
So this is kind of the weird thing about JavaScript. A lot of those things should be const. Even when when you do your for loop and it says for let I, that should actually always be const. Notice that when you see it, it's never const.
Right.
But it should always be const because it should your starting point should never change. It's just a weird thing about JavaScript that some people just accept let for what it is, but really most of those should be const. So when I wrote it, I know that that's supposed to be const because again, inside of that loop, it's not going to change. Why? I only need it for that specific iteration. And on the very next iteration, what happens? It's reinstantiated, right? So all those should be constant. Very rarely you'll see them, right? But that's kind of another layer to like a person's level of understanding of programming, catching little nuances like that. And you think, oh, that's not that complicated. You're right, it isn't. But that's the minimum level of understanding you're probably going to need to get a job. There's going to be way more complicated concepts like multi-threading and locking variables in databases, right? And atomic numbers, when you're getting 50,000 concurrent requests on the same, row of your database, like really tough problems to solve, right? Like you need to save all your energy for that. Like these for loops and like syntax stuff, this stuff's going to be in your back pocket by the time you get to your job. Or it should be because this stuff's easy.
Right.
I know it may not seem that way, and I don't want to diminish the difficulty of learning how to program. But ultimately, you really, when people say they solve problems, and you have no idea, I'm going to go on a little rant right now. I get so many, I watch a lot of interview videos, and people always talk about the passion of learning to program. Bro, you don't have passion. You just need money, and you need to take care of your family. That's why you're here. That's why I'm here. Okay, cool. Right? You don't have to lie to me. But they have like this passion for problem solving. A lot of people don't, and I myself necessarily don't either, right? You don't need passion, you need purpose, and you need to be very analytical, like when you go about solving these problems, and you need to realize that a lot of this stuff, right, needs to be in your back pocket for when you go to the job and you go to face these really complicated problems. Because coding, I'm sure I've said it in this class, coding's the easy part. Yes, I've said it. Yeah, coding's the easy part. Like when you get to your job, no one's going to be like, hey, how do you do this loop? No one's ever going to ask you that. But they are going to ask you why the third-party service that we're paying a big license fee for isn't integrating with our internal tools properly. And while you haven't worked on that ticket, it's taking you past 2 weeks.
Yeah. Yeah.
They're going to ask those questions, but they're
Mhm.
not going to ask you how to code something. I promise you that.
Yeah, they don't care how you do it. They just want you to get it done.
Yeah, and actually it wasn't until my 30-something years of age that I realized that it kind of doesn't matter how hard you work if you don't have something to show for it.
Right.
And my first year of programming was really tough for that reason, because I know I like almost cry myself to sleep saying, man, you're putting your heart and soul into it and you just don't have a lot to show for it.
Mhm.
And what Cisco said, results matter. The
Yeah.
effort, hopefully it's there, but if it's not there, you're going to get exposed quickly.
Mhm.
All that being said, don't lose faith. It will come. Have a wonderful day, guys. See you Thursday. We're starting with some pairs Thursday.
Bye, guys.
Bye, guys.
Have a good
Yeah.
night.
Bye, guys.